So today we're going to continue with yesterday's lesson on equations. We were introduced to what an equation is and what an expression is. And today we're going to look specifically at addition equations. So we are doing the Inquiry Lab Solve and Write Addition Equations. So our inquiry question, how do you solve addition equations using models? Go ahead and pause the video, read the initial question or problem that we're going to use to help us understand our inquiry question and answer what do you know and what do you need to find. So the problem says Brian played 2 baseball games last weekend. He got 7 hits in all. He had 3 hits in the first game. How many hits did he get in the second game? So we know that Brian played 2 baseball games last weekend. We know that he got 7 hits in all, and we know that he had 3 hits in the first game. And what do we need to find? We need to find the number of hits Brian had in the second game. So in the first hands-on activity, we're going to use a bar diagram. But first, we want to define our variable. In every equation, there are variables. So we want to define ours. We're going to use the variable S to represent the number of hits Brian had in the second game. So S for second game. Step 2 says use a bar diagram to help write the equation. Pause the video and fill in the answers to these spaces. The total length of the diagram represents what? 3 represents what? And then try to figure out what needs to go in each of these boxes based on the bar diagram. So let's see how you did. The total length of the bar diagram represents the total number of hits. So from this side to this side of the bar diagram is 7. That's how many hits he got in all. So the whole bar diagram is represented as 7 hits in all. The 3 represents the number of hits in the first game. That was also something that we knew. We knew that he got 3 hits in the first game. What we don't know, represented by our variable, is how many he got in the second game. So, if there are 7 in all, that means we can add the number of hits in the second game and the third game together to get 7 in all. So in the spaces here, you should have S plus 3 equals 7. Now, let's work backwards. Write the equation as a subtraction sentence and solve. So we have an S, we have a 3, and we have a 7. S plus 3 equals 7. Pause the video and try to come up with a subtraction problem that we can use that'll help us find the number of hits Brian got in the second game. So what we should have done was taken that 7 in all, subtracted the 3 games from the first, or the 3 hits from the first game, and use that to figure out how many are in the second game. So in these first boxes, we should have 7 minus 3 equals S. And we know that 7 minus 3 equals 4. So Brian had 4 hits in the second game. Notice we use subtraction to solve an addition problem. So we're not going to do this with a partner. You'll do this by yourself. But you're going to write and solve an addition equation using a bar diagram. Read the 2 problems and use the bar diagrams to help you come up with an equation and to solve the equation. All right, so let's see how we did. The first one says, in the 2008 Summer Olympics, the United States won 11 more medals in swimming than Australia. The United States won a total of 31 medals. Find the number of medals won by Australia. Okay, so what we know is that the United States won a total of 31 medals. So the whole bar is going to represent the 31 medals that the United States won. We also know that the United States won 11 more medals than Australia. So we are going to take 11 and let that represent some part of the United States medals. Now, we're going to use A as our variable to represent Australian medals, and let us add the Australian medals to the 11 medals that were won by the United States that were more. So we should get as our equation A plus 11 equals 31. The Australian medals plus the 11 more that the United States got should equal the total amount that the United States won, which was 31. Now, when we use a subtraction equation to solve, we would subtract 11 from 31, and that should give us a total of 20 medals. So the Australian medal count was 20 medals. And number 2, it says a lion can run 50 miles per hour. This is 20 miles per hour faster than a house cat. All right, so faster is our key term there. Find the speed of a house cat. So if we're using the model down here, the whole bar is going to represent the total distance or the total rate for a lion, which is 50 miles per hour. Okay, now we know that a cat is 25 miles per hour slower than the lion. It says this is 20 miles per hour faster than a house cat. So the house cat speed plus 20 miles per hour is going to give us the lion's miles per hour. Now notice here what we used is our variable. We used C for cat. So the cat speed is C plus 20 miles per hour gives us 50 miles per hour, or the speed of the lion. So there's our addition equation. C plus 20 equals 50. Now, if we are to solve the addition equation, we're going to use subtraction to do so. So we're going to take the 20 more miles per hour that belong to the lion and subtract it from the lion's total miles per hour to get the cat. So 50 minus 20 miles per hour gives us 30 miles per hour as the cat's speed. So in example number 2, we're going to look at a different type of model. We can think of an equation like a balance. The quantity on the left side of the equal sign, it needs to be balanced with the quantity on the right side. So they have to have the same value in order to be called an equation. To solve an addition equation using cups and counters, subtract the same number of counters from each side of the mat so that the equation remains balanced. So what you do to one side of the mat, you gotta do to the other side. Now let's check this out. We're using cups and counters. When we think about it, counters are counting for our numbers. 1 counter, 5 counters. And our cup is representing our variable, our unknown. We don't know what's in the cup, so the cup is representing our variables. So we're going to use cups and counters to solve x plus 1 equals 5. So we model the equation with 1 cup for 1x and 1 counter for our 1, the number 1. 5 counters for the number 5, and we have our equal sign. Step 2 says, use the model above. Cross out 1 counter from each side so that the cup is by itself. So I'm going to let you do that. Pause the video and cross out 1 counter from each side so the cup is by itself. Here's what that should look like. We should have crossed out the 1 counter on one side of the equal sign and 1 counter on the other side of the equal sign. Now the cup is by itself. Think about it. That's like taking 1 counter away from both sides of the mat. Now, step 3 says there are blank counters remaining on the right side, so x is equal to some number. Take a sec and fill in the rest of these spaces based on what we saw on the counter mat. Okay. Now, what we should have seen is that when we take 1 counter away from both sides, there are 4 counters remaining on the right side. So our unknown, or our cup, is going to be equal to 4. So the solution is 4. X plus 1 equals 5, so that's our original equation. Now, we're going to take our solution and replace it in the equation where the x was, just to check and make sure we did this right. So we have the expression 4 plus 1 equals 5. Well, if we simplify 4 plus 1, that does equal 5. And look, we've got a sentence that is true. 5 is equal to 5, so 4 is the correct solution here. And notice how we did that. We subtracted 1 from both sides so that the variable was by itself. So you've got 4 problems here that I want you to try and model using cups and counters. Do your best to draw cups, or if you want to, you can just use X's. It doesn't really matter. Try these 4. So let's see how you did. All right, so in the first one, on one side of the mat, we should have 1 counter and 1 cup, and on the other side, we should have 8 counters. So if we are going to get the cup by itself or the variable by itself, it looks like we need to take 1 away. So we're going to take 1 away from this side and 1 away from this side, and whatever is remaining is the value of our variable. So in number 3, x is going to be equal to 7 because we took 1 away from 8. If we look at number 4, our expression on this side should have 1 cup and 2 counters. 1 cup for 1x, 2 counters for the number 2. And on the other side, we should have 7. Now again, we want to get the counters away so that the cup is by itself. So that means we need to take 2 counters away. Now if we take 2 counters away from one side, we've got to do that to the other side so that the equation remains balanced. So now when we take 2 away from both sides, we see that our cup or our variable is equal to the remaining counters, or 5. If we look at number 5, our expression 3 plus x in this particular case. We've got 1 cup for 1x, 3 counters for our number 3, and on the other side, 6 counters to represent the 6. So to get the cup by itself, we've got to take away 3 counters from both sides, and we see that our cup is equal to 3 counters, or x is equal to 3. Notice in each case so far, we are taking away. What operation do we use when we are taking away? If you said subtraction, you're exactly right. Notice we're solving these addition problems by subtracting. All right, let's take a look at this last one and see if you can observe the subtraction. So we've got the expression x plus 5 equals 7. So we've got x plus 5 over here and 7 counters over here. It looks like we're going to need to take away 5 counters so that the cup is alone or the variable is by itself. And when we take 5 away from the other side of the equal sign, we have 2 remaining counters, or we're subtracting 5 from both sides of the equation so that x is equal to 2. Now, let's take this a little step further. Write a real-world problem that can be represented by the equation 9 equals x plus 3. Then solve the addition problem using a model of your choice. Remember, you've got the bar diagram and you've got the cups and counters that you can choose from. Pause the video and try this out. Remember, you're giving me a word problem, you're showing me a model, and you're solving the equation using the model. So here's a suggestion, and when I look at your papers, you should not have this written down. This is just a suggestion. All right, so a sample answer. Stephanie is 3 years older than her sister Raina. Stephanie is 9 years old. How old is Raina? So if we want to use the cups and counters to represent this, we've got 9 on one side of the mat, or one side of the equal sign, and we've got x plus 3 on the other side. So that would be 1 cup and 3 counters. Now if we want to figure out how old Raina is, we've got to take the 3 years older away from Stephanie's age and away from the expression that represents what is equal to 9. So we take 3 counters away from both sides of the equation, and we can figure out what Raina's age is. Raina is 6 years old. 1 cup on this side by itself and 6 remaining counters on this side. So x is equal to 6. Now, if you weren't able to write your own word problem, use this as an example and come up with your own. You should still have the same model though. Last one we're going to try together, and then you'll do some practice by yourself. So this one says, Terrell bought an MP3 player. Remember, that's like an iPod or something along those lines. He spent the rest of his money on an internet music subscription. So that's like iTunes. So he bought an iPod, And then he had to buy iTunes. And he bought iTunes for $25.95. He started with $135. How much was the MP3 player? Write and solve an equation using a bar diagram. So I want you to try this out. What we know is that Terrell started out with $135. We know that his internet subscription cost him $25.95. And what we're trying to figure out is how much he spent on the MP3 player. Remember, you need to define a variable. You got to use your bar diagram and show all of the parts. Remember what the whole length of the bar diagram should represent, and use that to write an equation. Then solve the equation. Now remember how we solved. If it's an addition problem, we took away or subtracted to solve the equation. So here's what we should have gotten. The whole length of the bar should have been the $135. That's what he started out with. That's how much he had to spend on the MP3 player as well as the subscription. We know that he spent $25.95, so that needs to be a small chunk of the bar diagram. And then the cost of the MP3 player is going to be the rest of the bar. And notice here, we use P for player as our variable. You could have used M, you could have used P, you could have used C for cost. Any of those variables would have worked as long as it was representing the cost of the MP3 player. Now, using the bar diagram, we've got a P and $25.95 representing the total. So our addition problem would be P plus $25.95 equals $135. Now remember, to solve, we're going to take away. So we're going to take away $25.95 from $135. And when we subtract, we get $109.05. So the MP3 player, or P, is equal to $109.05. Now here, you're going to take all of those experiences that we had in this inquiry lab and try to figure out what's going on here. If we look at the table, we're given addition equations. X plus 1 equals 3 is our example. Now to solve x plus 1 equals 3, we're going to subtract 1 from 3, and that should give us x. And we can simplify 3 minus 1, and that gives us 2. So x equals 2. So the solution to our equation is 2. We can replace the x with the 2, and the sentence would be true. Try number 10 on your own. We're going to check out how to do number 10 and make sure you understand. And then you'll do 11, 12, 13, 14, and 15, and you'll turn those into me. So, if you did number 10 like you were supposed to, we would have started out with y plus 9 equals 12. Our subtraction problem to solve for y, or our unknown, would be 12 minus 9 equals y. And then we would simplify 12 minus 9, which would give us 3. So our solution for y, or our value for y, would be 3. We could take 3, substitute it into the equation for y, and it would give us a true statement. So 11, 12, 13, 14, and 15 you're going to do on your own. Once you've got those done, come to me. You'll scan the QR code, get your answers, check them, and turn in your analyze and reflect section for credit. Thanks and have a great day.